Hello, everyone. You have stumbled upon or purposely found, and we hope it's the latter, the Global Astronomy Month 2014 Astro Arts Hangout on OPTICKS. Joining me today are Daniela de Paulis and Jan van Malvik, which I'm apologizing, I'm not Dutch, so I'm going to just sort of stumble through that brazenly. We also have with us, hiding in the dark, Nando, and we're here to bring you a special treat. We are reflecting sounds and images off of the moon and bringing them straight to you. Daniela, I'd love it if you could please provide some context for this wonderful set of things that we're going to be about to experience.
Thanks, Pamela. And welcome to all viewers from all around the world. Thanks to Global Astronomy Month and Astronomers Without Borders for hosting this event. Today we are going to bounce off the moon 12 images that have been submitted by people from all around the world. I'm very happy and proud of how many images I've received, and we made a choice of 12 images that are a mix of images from artists, amateur astronomers, and people from all walks of life from all over the place. And if we go to the first image, please, Pamela, I will tell a little bit about the context of this project. It should be the image of the radio telescope. Yep. Where we are streaming this event from at the moment. We are inside the cabin that you see in this image. And here in the Netherlands is 9 p.m. And we are going to transmit in a few minutes the images from Italy to the Netherlands by the moon. We started this work together about in 2009, so we've been collaborating for several years now, and together with me there is a great team of technicians. Calling them technicians is not good enough. They're incredibly talented and skilled people, amateur astronomers, radio astronomers, and with me we have Eine, Cor, Theo, and of course Jan van Mavlek, Mike, and Miriam from Astron. And if we go to the next image, I can explain a little bit about the technology. So this visualizes a little bit what we're going to do today for people who don't know much about the moon bounce technology. We are literally using the moon as a natural satellite. So the image will be transmitted from Italy and picked up in the Netherlands, receiving all the information of the moon surface, so to speak. So the images will be corrupted by the moon surface. The distortion you will see in the returning images are caused by several reasons. The main cause is the fact that the moon is not a very good reflector. Of course, it's a very rocky surface full of craters, so the radio waves, when they hit the moon surface, are scattered all over the place. Most of them fade away into space, and only a very small part returns back to Earth. So it's almost magic that we receive anything at all after a journey of about 800,000 kilometers. Also, there are many other things that influence the signals. Radio amateurs don't use any threshold in their communication. So every time we do transmission and the reception of images, we also receive all kinds of signals that are traveling the cosmos when we do the live performance. And the place where we are presenting this project is a very special instrument. Jan van Mavlek will tell a little bit more about that. So if we can move to the next image, Pamela, please. I'd like to ask Jan to continue.
Okay. It's the first moving radio telescope in the world. It was restored, and last week, April 5, it was reopened officially by Joe Taylor, K1JT, is his call sign. Joe Taylor is a famous person. He is a Nobel Prize winner. He won that prize with radio astronomy, studying binary pulsar with the Arecibo big dish, 300-meter dish. And he is also a radio amateur, and he wrote the special software for moonbounce, WSJT, as a lot of radio amateurs use and know about. So he was the perfect person combining radio astronomy, history, and radio amateurism to reopen this dish. And well, it was a big party. Many people were here, and it was great fun. And we were very, very happy that this dish is restored. We worked on this project from 2006 or something. It costed about 1 million euros. That's a lot of money, but now we are sure we preserved the famous instrument for at least another 50 years. So we are very, very happy you caught us at this very, very special moment. And there was another picture, I think. Let's see. Yeah, this was the official opening. There were 100 earth balls, inflatable balls in the dish, and Joe pushed the button and the dish came slowly down and all the balls dropped down, and there were a lot of children to catch all those balls. So it was a very festive thing, and well, it was really a great way to reopen this fantastic dish.
Okay, so as we are approaching the live show, maybe I can tell a little bit more about this project. As I said, this is a collaboration, 100% collaboration between me, artists, and the technicians, scientists here at the Dwingelo Radio Telescope. And today we are going to moonbounce images, as I said, from all around the world. And just to give you an idea of the context, this project is referring to an art movement that was founded in the 60s called male art. And male art was an art movement developed out of the Fluxus movement, and is considered male art is considered art only once it is dispatched. So at the end of the show, we will be printing the images, and we will be sending them out to all the participants as postcards. So once the participants will receive the postcard, in that moment, the postcard becomes art. This is according to the male art statement in the 60s. And the male artists, back in those days, and still now, it's a very active community. They created a global network, so they continue exchanging postcards and all kinds of objects using the mail as the main way of exchanging ideas and especially with visual messages. So what we add to this movement is the cosmos. So we add the moon and the cosmos as also another participants, and therefore I often refer to this project as a cosmic male art project. And yes, I think we can move on to the actual moonbounce. So we can start talking a little bit about the images that we received. The first one is by an artist, actually.
Sounds.
Oh, we've got some sounds. I'm sorry, I forgot about that. Very important.
Yeah, Nando will send some sound. How moonbounce sounds. He is first going to send some Morse code. So Nando, go ahead when you're ready.
Okay, just one few seconds. I have to tune it and switch to Morse code. I will send a call.
Okay.
Just to show how it sounds there. Okay, it should be running by now.
Okay, fantastic, Nando. And maybe now you can send some JT65.
Yes, so just again a few seconds to switch here.
Okay.
Well, okay, it should start now.
Okay. Excellent, Nando. Very, very strong signal. Fantastic, fantastic.
Okay.
And actually, this is the code that was developed by Joe Taylor, the man who reopened the dish a week ago. So this is what he made, and this is very, very strong code. It's possible to detect those tones even when you don't hear them. When they are 10 dB below noise level, then it's possible to even dig them out of the noise. So that's one of the things we do. But digging out of the noise is not necessary here because Nando has a 10-meter dish. He built it himself, magnificent dish, and we have a 25-meter dish. So that's all very big. But this is necessary for the pictures. And Daniela will tell something about the pictures because I think we can start doing the pictures now. Then I will change my camera now.
We actually have a question coming in from the audience. Hugo Burnham asks, do the tiny reflectors left behind by the Apollo missions reflect radio waves, or are they only optical reflectors? And what is it exactly that you're reflecting for these broadcasts?
Okay. Someone is answering. Okay. Well, I can answer this question. No, these are not. Let me see. I have to change. I have to do two things at a time, and that's a little bit difficult. Okay, there we are. No, those detectors that were placed by the missions do only reflect optical signals, a laser, for instance. And they do not add something to our signal. And so what we use is simply the surface of the moon. We simply reflect our signals of the surface of the moon, pure in a passive way.
So Daniela, what do you have to say?
Okay, so the first image is from an artist called Gianni Piacentini, based in Italy. And I've chosen this image because, well, it was created especially for this event, and also it's a very geometric image, so it will be interesting to see how it is when it returns from the moon.
Can start?
I think we need to see the original image.
Yeah, better, so I know what to send.
I think it will help.
Okay.
So Pamela, if you can please show the image number 1 from the submissions. So we can show the difference between exactly what an image looks like before and after returning from the moon. So this is the original image by Gianni Piacentini. And now, right at this moment, Nando is going to send the radio waves to the moon, and in 2.5 seconds we will receive the reflection. I also asked the people who submitted the images to send me a short message to go with the visual message. So I will read for each image also the text. and as if it was written at the back of a card. So I consider these images as virtual postcards.
Someone is sending JT65 on this frequency, Nando.
Shit, I'm sorry. No, I've been closing JT65. I was not even calling, just to avoid someone to answer. Let's wait. I think it will understand it. Do I have to resend the picture?
So what's happening right now, Daniela?
No.
Although I'm not
sorry, my fault. My fault. I had WSJT still transmitting, so it was my fault. I'm going to resend the picture. Is that okay?
Okay, we'll try to explain briefly. As far as I understand, the image was sent, that we use a certain system for receiving them, and maybe it was not, the software wasn't 100% set for receiving it. So we'll tell you a little bit more about it later.
So while we're waiting for this to happen, do you want to explain more about the different images that came in?
Yeah, sure. Jan, the big window, okay, and the lower third, okay. Yeah. This image, as I said, was created especially for this performance, and it's coming back very patchy. The message at the back of the card was to all the vehicles in the skyways, wishing safe journey, and then a pleasant return. So what we see in the moon-bounced image is a lot of distortion. The colors are contaminated by pixels of all different colors. So with this kind of image, it's very easy to see what happens to a moon-bounced visual data. So
now I need to remove the lower third.
Okay,
I need to
great.
switch back one moment.
So Pamela, if we can please move on to the next one, to image number 2 by Brittany Gutierrez, who I think, I assume is someone from the Astronomers Without Borders community. She didn't say much about herself, but she sent an image of her 2 children.
Already coming in.
Okay, and this one is very fast. It's returning from the moon. And Brittany's message is, I love you to the moon and back, love infinitely. And she lives in Virginia. This one. And of course, there is a lot that can be said about what's going on during the transmission. You probably noticed that the image keeps shifting
that has something to do with the synchronization.
Yes, that's something that we always have when we receive images from the moon. So it's part of the whole process. If we move on to the next image, the original one, yeah, okay. This is also submitted by an artist, Adam Brown from London. Adam also sent us his coordinates, latitude 51.5042, longitude 0.027276. The image is already returning from the moon. And the message at the back of the card is, "Sorry, no longer at this address." The title is "No longer at this address, burned out house, Queensland, Australia." The colors of the images are a little bit different from what you probably see on the screen at the moment. We are relaying the images via camera, so there is some distortion with the translation of the data. But people who will receive the postcards will see the image in a much more clear and truthful colors. Okay, we can move on to the next one. The next image is by Giorgio De Finis, a photographer from Italy. It's a black and white image, so again, something different. It's a series of, Giorgio made a series of works called Portraits Before Departure. And this image shows Daniel from Peru, dressed as the first cosmonaut in Metropolis, which is the location in Italy where Daniel lives at the moment. So I can see already the reflection. The black and white image is filled with colors. This is because we are using a system of image transmission set for colors. So if we were transmitting with another, well, how would you call it, Jan? Mode, then we would have only black and white. Okay, next image is from Richard Lowenberg, living in New Mexico. Okay. It should be text. Okay, that's it. And Richard was very laconic. He only said, "Beam me up, Scotty." That's his message. Jan, would you like to say more about the images, or do you think we explained enough? Okay. Okay, thanks, Richard, for this wonderful text and colorful image. Great, so we can move on to the next one. You probably see at the back some movement. These are the cameras, radio amateurs. So the cabin is very lively, and later we will give you a tour of what's going on in here. The next image is by Andreas Imse, who is part actually of the ham radio community. We know him, we met him personally. He's a radio amateur from Germany, and he sent us the image of his QSL card. A QSL card is an image that radio amateurs exchange at the end of each two-way contact to notify each other of the contact. And I assume that this is a picture that Andreas took himself of the moon.
Yeah.
And Andreas has submitted a very beautiful text with this image. It's very long, so I won't be able to read it completely, but it's a text from a novel called Guess How Much I Love You by Sam McBratney. And the core sentence is basically a discussion between two hairs. And the core sentence of this long text is, "I love you right up to the moon," said the little nut brown hare. "Oh, that's far," said big nut brown hare. "That's very far." I'm sorry for my not very good acting skills, but this, I guess, is the origin of the famous quote, "I love you to the moon and back." So it's from this novel of an Irish writer called Sam McBratney. Okay, thank you, Andreas. And the next image is from North Carolina by Tavi Greiner. I hope I'm pronouncing the name correctly. And yeah, I really like this image because of the colors and because I felt that it can connect with everybody watching a sunset by the sea. And the message we got for this image by Tavi is, on November 3rd, 2013, we watched the sun and moon become one, as Luna, Earth, and sun briefly aligned for a sunrise, hybrid solar eclipse. I think the moon-bound image is just as amazing,
Beautiful.
At least for me. Thank you, Tavi, for this timeless, universal image. The next one is by Sarah Jane Pell from Australia, Melbourne, Australia. She also sent us her geographical coordinates. And in fact, she is on Earth 37.8098 south, 144.9648 east. She has a long message that is really beautiful. I would like to read it to you because Sarah actually wrote it especially for this event. And she says, "Dear Lunar Gaia, I have looked lovingly at you in the face almost every week since I can remember. And yet every line, every crease and smile has remained perfectly serene. It is time to tell you that your timeless beauty and celestial illumination has been a mesmering and anchoring force in my life. Deep within you, continue to affect us. Continue to bless us with your stillness, your sharpness and wit. Continue to permeate our mythologies and corrode our ambitions with the harsh realities of your extreme silent cadence, so that we can better understand our place in this universe. Each time you bounce images and mirror back at us the reflection of who we really are. Without you, dear moon, the earth of our planet will stagnate and die. Without you, the night will be eternal. Your humble earthling admirer, Sarah Jane." Thank you, Sarah Jane, for this wonderful contribution and very nice. The next one is from Japan, also an artist called Yoshi Koinuma. And Yoshi's been very generous to offer for this project the image of one of his artworks, one of his paintings. Okay, voila, this is the original image. Yoshi says, I've never heard of a constellation called the Mole, so I would like to send a message into the universe to call a new constellation Mole. Yoshi works with animals, the cosmos, so is very interested in connecting earthling animals to the stars, and his work is very original. Okay, the mole has become slightly unreadable.
It's an X-ray mole.
It's an X-ray mole, so yeah. Okay, thank you, Yoshi, from Japan. The next image, again, is from London by Melanie King. And I know that Melanie works with pinhole camera. She's an artist that is very interested in reusing this old photographic medium for contemporary photography. And this image is simply unknown, untitled, not message, so just enjoy as you wish. Because the original is very fuzzy, so it's going to be quite interesting to see what is going to come out after the moon bounce.
Nando is producing excellent pictures.
Yeah.
Thank you.
We can still see the shadow of the cat. Squeezing the eyes is a lot more clear. Okay, thank you, Melanie, for this very poetic black and white image. And the next one is from, I guess, the US. I don't have the exact location for this one, by another artist called Michael C. Turner. And the title of this image is Eternal Star, Cosmic Manifestation. So as the image returns from the moon, I will read the message at the back that says, I would like to send my space painting to the moon and back to signify the historical and scientific importance of space art to the ongoing exploration of space. Indeed, space art has been always very influential to also space science. So thanks, Michael, for reminding us. And of course, all of these images will keep traveling into space after the moon bounce. So as we said earlier, only a small part of the radio waves is reflected by the moon surface, and the rest keeps traveling at the speed of light. So it will reach very far away in the cosmos. And okay, next one, the last one actually, is from Michael Garrett, who is actually here in our cabin. And he sent us an image, which we all know, but surprisingly, we never moon bounced this image before. So indeed, it had a priority in this particular event. And the message at the back of the card is 12:01 alarm. Thanks, Michael, for sending Buzz Aldrin back to the moon again. Maybe well, some astronauts is watching this program, and yeah, you never know. Well, thank you. We received about 60 images, and I kept receiving them today. We couldn't moon bounce them all. We can only do about 10 of them because of technical limitations.
And time.
And time, of course. We are going to print these images, send them back, as I said. And we might moon bounce some more images, perhaps in the next few weeks. So please be patient. We will slowly get back to you. And in 2 or 3 months' time, you might receive an image returning from the moon with our message at the back of the card and our signatures to testify that this event really happened.
On the tour.
So we have an additional question coming in from the audience. What is the beam width in arc seconds when it hits the moon?
That's a nice one. I will switch back for a moment to my own camera. You can see me. This one. Okay.
There you go.
Okay. There we are. Well, we do this on 23 centimeters. That's 1.2 gigahertz. And the nice thing is that our dish is 25 meters, and on that frequency it has a beam width of half a degree. And the nice thing is that the moon also is half a degree. So that means that all the energy we transmit hits the moon. So you could say in retrospect that this dish was designed as the ideal 23 centimeter moon bounce instrument. Of course, it wasn't designed that way. That's just coincidence, but that's fantastic.
So just to expand on that a little bit, how big is the reflected beam when it comes back at Earth?
Oh, that's huge, because the moon is a sphere. That's a pity, because if it was square or flat, it would reflect much better. But because it's a sphere, well, the beam is about 180 or maybe more degrees wide. So that's why the signal that returns is so unbelievable weak. The attenuation, the total attenuation, if you put that in a figure, is a 1 with 27 zeros. So that makes it very, very difficult to bounce signals.
And the important thing here to remember is, this is the audience. So audience, when you think about this, since it's a sphere, it's essentially taking what we send at it and then bouncing it out over a full 180 degrees.
Right.
So if you've ever seen the picture coming off of a fisheye lens, well, this is the inverse of this. It's sending out a fisheye picture.
Yes, indeed. That's a good thing to say it. Yes.
So for those of you wondering where we're getting the questions and how you too can participate, wherever you're watching this, you should see a link to the Q&A app. Go ahead and leave your question through the YouTube Q&A app, and we will try and get to it here on air. This broadcast is being presented as part of the Global Astronomy Month AstroArt Hangout series. We're going to be bringing you a whole series of small hangouts that focus tightly on ways that art is being used or inspired through astronomy. In this case, we're taking beautiful photography and making it beautiful in a different way by changing the images, by bouncing them off of the moon. If you want to find out more about this program, go to the Astronomers Without Borders website and you can learn all about this series, because it doesn't happen just during the month of April. There's actually blog posts and events that happen throughout the world that you can be part of.
Okay, Pamela, while we wait for more questions, we were thinking of doing a tour of the radio telescope because this instrument is incredible, it's very special, possibly the only instrument in the world that is fitted and available for this kind of thing. So
Yes.
we're all very proud of this telescope. That's where we are. That's me, hello, from another perspective. The person at the camera is Theo. Okay, and Michael Garrett, Miriam Janssen. And yeah, it's me again. And Jan, would you like to say something more about the Dwingler Radio Telescope? It has so much history that maybe
Yeah.
difficult to be condensed in a few minutes. But
yeah, there is a lot to tell about. But one of the first things, it was originally built, of course, for radio astronomy in 1956. And it was the first of its kind in the world. And one of the things it more or less discovered was the structure of our own galaxy. We now know that our galaxy is a disk filled with stars, but until then we only saw the Milky Way up in the air. That's that light band of stars, and you cannot watch through this band. That's not possible. So with radio waves, you can look what's behind it. And that way, using this telescope, they found out that we are really a disk, that we are a nebula, a galaxy with all kind of spiraling arms. I sometimes say if we had CNN during those days, it would have been breaking news. And it was really the first time that humanity could see that we were really a galaxy. Well, and that this is only one of the stories. It all began here. Today we had some visitors, and I told them this is the holy ground of radio astronomy. And the whole story started here, and that's, well, I always feel enormously privileged to be able to be here and to use this magnificent instrument. And I'm so happy that it's fully restored now. So, yeah, it always feels like a party.
If I may say something about this, we froze the image at this point because these are the QSL cards that we mentioned before. Radio amateurs exchanged them after making contact with each other, and this relates very well with the project that we just presented. It's all about mail art. Global international network. So these are only a selection of postcards from all around the world. And we can finish perhaps the tour of the cabin. And I would also like you to, yes, please, Theo, just, I would like you to see the rest of the cabin. And the two others, cameras team, Eine and Core. Again, I'd like to remind that without the cameras team, we wouldn't be able to do any art project at this telescope. So thanks to all cameras.
Noel Rupenthal is asking, if you tried to stream video this way, how would the quality look? And I think this goes into how long it takes to send out the signal as well. Could one of you discuss the pros and cons of trying to send video?
Oh, yes. Okay, yeah. Well, actually, that was the first question, more or less. Daniela asked us in 2009, is it possible to do moving images, to do a movie via the moon? Well, it's not impossible, but you need a huge disk, because we use a process to transfer images that's called slow scan television. You saw the pictures coming in line by line by line, and that uses rather small bandwidth technology. So all the energy we use goes into that small bandwidth. But to transfer video and audio at the same time, a normal television signal, or a streaming signal or whatever, you need much more bandwidth, and so you need to project much more energy on the moon. So you would need a much bigger dish. We did some calculations, and we think it should be possible using the Arecibo dish, 300 meters at one end, and the 25-meter Dwingelo dish at the other end. Well, unfortunately, the Arecibo dish is still used for scientific work, so we can't do that experiment. So therefore, we switched to slow scan images and one picture at a time using the technology we use. So that, and it's still amazing. I mean, you see those images, and remember, we use very big dishes to produce this kind of, well, totally not high definition images, but it's great fun. But to do television, it would require much bigger dishes.
So one additional question. When we talk about radio astronomy, it's usually we're usually discussing receiving images. Are there radio telescopes out there that can't send as well as receive, or is this radar capability fairly ubiquitous?
Well, the dish is only a mirror, and it depends on what you put in the focal point. But normally, radio astronomers only receive, because there is no point in transmitting to stars, because it takes many years, thousands of years, millions of years before those signals reach those stars. So transmitting for a radio astronomer is something very strange. It took some talking to some of the radio astronomers here at Astron before they understood what we would like to do. So, because radio astronomers normally only listen, they receive, but the process and the instruments, the things that are necessary, are not so difficult. I mean, if you have a receiving dish and you add a transmitter somewhere in the process, you could easily transmit with it. It works fully vice versa.
So we don't have any more questions at the moment coming in from our audience. Daniela, would you like to highlight any more of the things that AstroArt is up to during this Global Astronomy Month?
Yeah, sure. Thanks, Pamela, for asking this question. I'm one of the AstroArt's organizers, so we brought together this program. It's including several art projects that can be presented online. So they're meant to be global projects that can be viewed at any time by everybody all around the world, and that often include audience participation. So after this program, we have another Hangout, I think on the 21st of April, together with an artist called Erika Blumenfeld, who is a photographer, and her project is about collecting stories about the night sky from people who have had the luck to experience a real night sky, which not all of us actually have the chance to experience. Personally, I don't think I've ever experienced a true night sky, 100% true night sky. And also on the 22nd of April, we have another AstroArt Hangout together with Marty Quinn, another artist based in the US, who will talk about his project in collaboration with NASA called Crater Live, which is a radio station that he created especially for transmitting the sounds of the cosmic wave hitting the moon. So it's a very interesting project. And yes, I think that's it for AstroArt, but there are lots of other events in Global Astronomy Month. So.
And for people who are interested in science movies in general, you and I will both be at the Alamak Film Festival next week in the Czech Republic, and perhaps some of our audience will see us there.
Hopefully, yes.
So this has been a production of CosmoQuest. We are someplace that if you want to do science rather than art today, go map out the moon, find some craters on Mercury, and trace out the trenches on the asteroid Vesta. CosmoQuest.org is your place for doing science, and we are working in collaboration with Astronomers Without Borders to produce this Global Astronomy Month AstroArt Hangout series. Please check out both CosmoQuest.org and AstronomersWithoutBorders.org and learn all you can about this amazing cosmos that we share, and let what you learn inspire your art. So thank you so much, Daniela, Jan, Nando. This has been a great hangout, and I've really enjoyed all the different things that you've been able to bring us. Thank you so much for joining us.
Thank you.
Thank you.
Thanks to you.